Neuroplasticity. When your brain changes with every thought. Have you ever thought that the brain you have today is not the same as the one you had yesterday? Every time you learn something new, experience a strong emotion, or ponder an idea, your brain subtly but profoundly changes. This isn't science fiction, it's a scientific fact. Scientists call this phenomenon neuroplasticity, the brain's remarkable ability to restructure itself throughout life. From childhood to old age, picture your brain as a vast bioelectric network with over 86 billion neurons connected through trillions of synapses, the junctions that transmit signals. Every thought and action activates parts of this network, and over time, it reshapes itself. For example, when you learn to play the piano, your brain doesn't just memorize notes. It forms new connections between motor and auditory regions. Research from the 19th century hinted at the brain's flexibility, but it wasn't until the 1960s that scientists like Michael Merzenich provided clear evidence through animal experiments showing the brain could reorganize after injury. Today, with brain imaging technologies like fMRI, we can see neuroplasticity in action every day. Neuroplasticity isn't just about learning. It touches every aspect of life. When you worry about work, your brain strengthens negative thought pathways. Conversely, practicing gratitude builds positive ones. This offers hope. You're not stuck in the past. Your brain can change and you're in control. Let's dive deeper into the core concepts. In the 20th century, it was widely believed that the brain stopped developing after age 25. This view stemmed from the idea that the brain was a fixed organ, growing rapidly in early life and then gradually declining. However, recent research has overturned this. The human brain continuously rewires itself every time you learn, love, suffer, or hope. Neuroplasticity is the brain's ability to form and reorganize synaptic connections, especially in response to learning, experience, or injury. The history of neuroplasticity research began in the late 19th century when William James mentioned plasticity in behavior in 1890. By the 1960s, animal studies showed the brain could recover from damage. And in 1998, Bruce S. McEwen explored this plasticity in depth. Neurons form new connections, while unused ones weaken, following the use it or lose it principle. This means you're not limited by your past. You can reshape yourself. For example, in blind individuals, the brain's visual cortex can be repurposed for auditory or tactile processing, demonstrating adaptability. In daily life, frequent negative thinking makes your brain more prone to that state. Conversely, learning a new language can increase gray matter density in the hippocampus. Neuroplasticity occurs at all ages, though it's more pronounced in children. Adults can still achieve significant change through deliberate practice. This concept isn't just theoretical. It's applied in stroke rehabilitation, where patients train to regain lost functions through brain reorganization. Research from the Mayo Clinic shows neuroplasticity enables the brain to adapt and grow even in old age. Understanding this positions the brain as an ally, ready to evolve in the direction you guide it. Neuroplasticity operates through two primary mechanisms: synaptic plasticity and neurogenesis. Synaptic plasticity involves changes in the strength of connections between neurons, either strengthening or weakening synapses. When two neurons fire simultaneously, their connection strengthens, following the Hebbian principle. Neurons that fire together, wire together. Neurogenesis is the formation of new neurons in the hippocampus, the brain's memory and learning hub. While adult neurogenesis primarily occurs in the hippocampus, it plays a critical role in forming new memories. Each repeated thought creates neural pathways like trails in a forest. The more you walk a thought, the deeper the path becomes. This explains why you can become addicted to certain thought patterns, positive or negative. These mechanisms involve molecules like BDNF, brain-derived neurotrophic factor, a protein that promotes neuron survival and synapse formation. In childhood, the brain is highly plastic, forming and pruning millions of synapses. In adults, chronic stress can reduce neurogenesis, while exercise boosts it. For instance, studies on mice show enriched environments stimulate neurogenesis, improving cognition. Additionally, structural plasticity involves changes in neuron structure. like growing new dendritic branches, while functional reorganization allows one brain region to take over another's role after injury. These mechanisms make the brain a dynamic system, constantly adapting. Emotions don't just affect your mood, they shape your brain's structure. When you live in anxiety, the amygdala, the fear center, expands, heightening stress responses. Conversely, practicing gratitude strengthens the prefrontal cortex, the center for calm and clarity. Your brain learns from the emotions you repeat. Thus, changing emotions changes the brain. The amygdala and prefrontal cortex interact closely in emotional processing. The amygdala handles basic emotions, while the prefrontal cortex regulates them. In anxiety, their connection weakens, making emotional control harder. Research shows labeling emotions reduces amygdala activity. Visual. 2 brains. One glowing red with stress, showing an enlarged amygdala. The other a serene blue, highlighting a robust prefrontal cortex. For example, in PTSD patients, the amygdala is overactive, but cognitive therapies can restructure the brain. Positive emotions like joy increase BDNF, boosting neuroplasticity. By managing emotions, we can shape the brain positively. Science suggests it takes about 66 days on average to form a new habit. Not 21 days as commonly believed, though 21 days can initiate the process. Each time you focus, meditate, or journal, you train new neurons, like lifting weights for your brain. 3 habits to activate neuroplasticity. Learn something new daily, a language, instrument, or skill. Enhances brain connections and cognition. Meditation and mindfulness. Reduces amygdala activity and increases gray matter in the prefrontal cortex. Studies on MBSR, mindfulness-based stress reduction, show meditation improves emotions and brain structure. Write down positive thoughts. Reinforces new neural pathways and reduces anxiety through journaling. Combined with mindfulness, it enhances self-awareness and behavior change. Daily practice. Start with 10 minutes of meditation, learning 1 new word, or writing 3 things you're grateful for. These small actions accumulate, leading to significant change. Your brain is a bioelectric garden. Sow negative seeds and anxiety will grow. Plant seeds of mindfulness, and wisdom and peace will flourish. Neurons that fire together wire together. The neurons that activate together shape your reality. This Hebbian principle emphasizes that repetition molds the brain. If your brain rewires itself with every thought, what are you training it to become?